Okay, so a slant asymptote is exactly what it sounds like. It's a slanted dotted line that the graph is going to approach as it goes to the right or to the left to infinity. So it's similar to a horizontal asymptote. You're technically allowed to cross them, just like a horizontal asymptote. Vertical asymptotes, we are not allowed to cross. Okay, but the slant asymptote is only as you go to the left and right forever. So you can cross sometimes in the middle. But this is going to be what we focus on today is how to actually find the equation of the slant asymptote. So we have to use long division. All right, so it's been a while since we've seen long division. So we have to divide the numerator by the denominator, and then we basically ignore the remainder. All right, so we're going to look at an example, and we're going to find the slant asymptote for this rational function. Okay, so because the degree of the top is 3 and the degree of the bottom is 2, this falls under the slant asymptote case. So there's no horizontal asymptote because the degree of the top is bigger than the degree of the bottom. But because it's exactly one more, there would be a slant asymptote. So we're going to set up our long division bar. If you remember what that is, so we've got our division bar, and we put our numerator inside, denominator on the outside. So when we're doing long division, to figure out what goes on top, all right, we have to ask ourselves, what do you multiply x squared by to get 2x to the third? All right, so what do we multiply x squared by to get 2x to the third? Well, that would have to be a 2x. So we put that 2x on top. And now we want to take that 2x. We've got to multiply it by this function, so it has to get distributed. We put it underneath, and then we subtract. So that's how we do any type of long division. So 2x times x squared will be 2x cubed. 2x times negative 4 will be negative 8x. And then we have to subtract. So since we have two terms, I like to put it in parentheses. And we're subtracting both terms. So when you subtract here, the 2x cubed minus 2x cubed will cancel. And the negative 3x minus negative, so it becomes plus 8x, will give us a 5x. And then we can bring down the next term, which is plus 1. But when we're looking at this function, we want to figure out when do we get to our remainder. Well, the degree of this function is 1. And the degree of what we're dividing by is x squared. So once this degree is smaller than what we're dividing by, it's considered our remainder. So we're technically done. So this is our remainder. So that means we're going to ignore it because that's what this rule says up here. We're going to ignore the remainder. And this is the equation of our slant asymptote, which is linear. It will always be linear because of this rule that we set up. The degree of the numerator is exactly 1 greater than the degree of the denominator. So when you're doing your long division, you're always going to get a linear function here. And then we just write it as an equation. So the slant asymptote is going to be y equals 2x. All right. So when we graph it, when we get to the point of graphing, it's going to be put in as a dotted line. All right. It's just not going to be horizontal or vertical. It's going to be slanted. So on Wednesday, we'll kind of put it all together and look at the graphs. So we'll put together intercepts, vertical asymptotes, horizontal asymptotes, holes, and slant asymptotes. But for your assignment tonight or today, you're just going to do identifying some of the parts. And now we're going to include the holes and the slant asymptotes as well. All right, so that's going to be posted on Google Classroom. It's called Investigating Functions. So we're not going to actually be graphing it. We'll do that on Wednesday. So this assignment will be due Wednesday, all right, 9 a.m. So you have 2 days to do it. If you have any questions, email me. You can hand it in before then, all right? Like I said, if you get it done before that, you can turn it in as well. Okay, guys, so I will see you Wednesday when we put this all together and start actually graphing.